Hi everyone, this is Mrs. Her again, and we are now on 1.3.6's classwork. This will be from 324. So what I went into was I went into Desmos and I substituted in 14A, B, C, and D. And what we're going to do is we're going to use Desmos and we're going to see if in fact any or all of these are even functions. And again, these are all quadratics. You see the x squared term. So let's take a look at the red one. And again, what I love about Desmos is it has the little colors there that let you know. This one's purple. It kind of looks a little blue. So we have red, blue, green, and purple, but I'll help you on the screen. So first we've graphed 14a, which is y equals 5x squared. And so we have a is right here. It's a red graph. And what has that 5 in the front done? Well, that's a vertical stretch by a factor of 5. But now if I ask you, does one side land on the other if we reflected about the y-axis? The answer is yes. And so 14a is, in fact, even. Okay, 14a is an even function. And now I'm going to take a look at, how about number 2? Letter B. Letter B is this one over here. And if you see, it's been translated to the right, and we knew that from the original equation, because if we have x minus 2 in the house horizontal, the opposite of what I think. So it looks like it should have gone left 2, but we know there's a minus in the original formula for the quadratic in vertex form. And so it moved, in fact, to the right 2 blocks. Does everyone see that blue one? Now, if my y-axis is this black line right here, and I attempt to take this blue parabola and shift it over, will it look identical to the parent function? If I translate it, if I reflect it over the y-axis, it's going to look something like this. And that's obviously not the same as the parent function. And so 14b is not an even function. I want you to make a note of that. Whenever you have a transformation that's inside the house like this, that is a horizontal slide, either left or right, you will not maintain that even function. It's not going to reflect over the y and still be the same function. Let's take a look at the green one. In the house horizontal, so we definitely have a transformation here, but it's not a plus or minus with the x. It's x divided by 3, which is the same as x times 1/3, and so that's a horizontal either compression or stretch. Remember, in the house, the opposite of what I think, if it was 1/3 outside, that would be a vertical compression. But because it's inside, it's actually a horizontal stretch by a factor of 3. Remember, it's the b value, 1 over b. So if you take 1 over b, the 3 would flip up top. And so it's going to be a horizontal stretch by a factor of 3. And if I take a look at the green function, whoa, definitely was stretched. So again, from our parent function of y equals x squared, you can see that it's been stretched out that way. It could also look like a horizontal compression, but either way, both of those, any stretch or compression of your parent function, if the parent function was y equals x squared, in other words, there's been no horizontal translation, then this is in fact still an even function. And let's take a look at letter D. So far we have even, no, even. Taking a look at the last one, now that is a parabola quadratic that has shifted up. The k parameter has gone up 6. So if I take a look at it, and again, love Desmos, guys. This is a free download for you, and you can do it on your phones also. So if I look at D, it's up here. I know the blue and purple look similar, but it is a purpley shade. And if you were to say, if I reflect this about the y-axis, does it actually land on the original function? And the answer is yes. So what do we learn from this example? When we have a horizontal shift or translation, left or right, the original graph has been moved, and it will not maintain that even status, even function. However, if you have a vertical translation up or down, and again, we've done that whenever it's just shifted up and down, but no other transformations have taken place, it will always stay an even function. Let's take a look now at number 15. So again, going back here, what are the correct answers? Even, no, the letter C is even, and the last one is also even. So the only one that is not is the one that has undergone a horizontal translation. That one took it away from being even status. Taking a quick look at number 15, they're giving us g of x is a new function. And again, you can look at the picture in your workbook, but we just want to, just by looking at it, we know enough now that we should be able to say what happened. So this negative outside always produces the same result, and it's a reflection over the x-axis. Remember we said when the parabola was negative, we knew that it opened down. What does this do in here? In the house horizontal, the opposite of what I think, there's a +4, so in fact it went to the left 4 units, and this is outside, it's not inside the parentheses, it's outside, which we could write it as 1/3 f of x. So since it's on the outside, that is a vertical compression by 1/3. Okay, and I'll show you the answers in a minute. I just wanted you to think for a moment. So this other one is g of x is equal to f of 2x plus 2. Well, that plus 2 is our k parameter, and everyone should see when it's not touching anything, it's all the way on the outside. That is a vertical shift or translation of 2 units up. In the house horizontal, the opposite of what I think. So if that 2 were outside, that would be a vertical shift up or down. But since it's inside, it relates to moving left or right. Remember, when it's inside, it's 1/b. So if it was outside, it would be a stretch. Since it's inside, it's a horizontal compression by 1/2. Just remember 1/b. In the house, it's the opposite of what you think. And then what I've done here is I've made a little synopsis of what we notice. It was reflected over the x-axis. It was shifted left by 4 units, and it was vertically compressed by a factor of 1/3. Now again, don't take my word for it. Go ahead and put this into Desmos, graph your original function, f of x, okay, and then do the g of x function, and then you should be golden. And then looking at number 16, Ava, hold that for a moment, please. 17, 18, hold that. Thank you so much. Okay, so when I look at number 16, we went over those also, and sorry guys, just trying to get us all bearing straight. Okay. All right, so the original function, they said f of x was x squared. I just want you to make sure that you know f of x, the original was x squared, because you don't see it here. It's given in the directions. Okay, so this is a horizontal compression by 1/2, and I said recall that horizontal compressions and stretches are 1/b, so b is 2, so the compression is by 1/2. Okay. And translated up 2 units. Okay, so that was 15 and 16. 17 and 18, Ava? I hand it to you. Okay, here we go. 17 and 18. Having one of those days, guys. Okay, number 17 is given to you as a picture, and they're actually asking you to try to use a little exploration, discovery, and come up with a formula. So all I know is what's given here. So I'm given a picture. Again, this is in your workbook, and number 17 and 18. So here I go. What do I know? The vertex of this graph occurs at 2, 12. Well, we know in vertex form the h, I'm going to substitute the 2, the k, I'm going to substitute the 12. Since this is a parabola that opens down, I know that the a is negative. What I don't know is, has this been vertically stretched or compressed? So what I want you guys to do is I actually want you to go into Desmos, plug this in, and I want you to play with some numbers. Put in -2, put in -8, try 1/3, try 1/5. What you want to do is see how close you get to this. And after you play, whatever you get is the closest answer. Again, I'm not going to take off points if it's wrong. This is a discovery activity. So I'm looking to see what you guys can come out with that. I know I'm not going to give that to you. looking at number 18, we have another stretched out parabola. Looks like a very tightly drawn rope, has only a little bit of slack to it. So here I go. 1, 4 and 7, 4 are two given points. What do I know? The vertex is actually given as 4, 3.5. So I can go into vertex form and say, what's h? H is the 4, so I substituted that value in. K is 3.5. I've substituted that in for that. So since it opens up, I know it's positive. A is definitely positive. But it looks like it's been, stretched to some number. So, I'm sorry, compressed, because it's gotten squishier. So since it's gotten compressed, I'm thinking this is a fraction. Try a half, try a third, try some fractions. Do this on Desmos and come up with whatever the closest match you can to the given numbers. So they also ask you for the domain. The domain are the allowable x values. X goes from 1 to 7. They do not ask you for the range, so just worry about the domain. Going back up to number 17, I apologize. That one also you are asked for the domain. And so the domain goes from 2 to 8. Okay, one more video done. Make sure that you self-check your responses, and then you snap a picture of the completed workbook pages and you deposit that in your Google Classroom. Have a good day, guys. I'm going to try and get caught up with last week's work, because again, we are behind, but I did not want to go too fast and lose some of you. Razira, I apologize for making so many postings, but I was behind and getting caught up on Algebra 1. We're getting there. Stick with it. Have a great day today, guys. Again, you don't have to do this till Monday. We're just getting caught up.